Hello and welcome everyone to the 35th video lecture of Quantitative Techniques, Semester 3, Model number 3. In today's video lecture, we are going to start with the third video lecture, that is a random variable. Today we shall see the theory part of it. So, what is a random variable? In our previous video lecture, we have seen about various experiments that have been conducted, and we have found out the probability of those experiments. Whether it is a rolling of a dice, tossing of a coin, picking up of a ball, all these are random experiments which lead to outcomes. Now, each of these outcomes are associated with certain probabilities, and random variable just is a step forward to understand at what frequency these variables or outcomes do happen, or what are the chances of these outcomes happening. So, by definition, random variable is a function which assigns a real number to every sample point in the sample space. So it is a random variable is a function. So the function, say f of x, which assigns every real number a real number to every point in the sample space. Now example for this: suppose if you toss a coin up, okay, what are the possible outcomes? The possible outcomes I am writing there at the top. So your sample space will be h comma h h t t h t and th, right? This is your sample space when you toss two coins at the same time. Fine. So you can see that there are two heads here, there is no head here, there is one head here and one head here. So suppose if the function, if we say that function is, you have to find the number of heads that are coming, okay, the number of heads that are coming there. So number of heads, if suppose function x represents number of x, I'll just write this. If x represents a function, okay, or a variable which gives the number of heads that will come when you toss two coins up simultaneously. How many heads you might get at the maximum when you toss two coins simultaneously? 2 heads. What is the minimum number of heads that you will get? 0 heads. And what are the other possibilities? 0, 1 and 2. So there are only there are 3 outcomes possible. So if x represents here the number of heads that will show up when you toss two coins simultaneously, then the values that it can take is 0, 1 and 2, right? So 0 heads coming up, 1 head coming up and 2 heads coming up. So in any experiment when you toss the coin, two coins simultaneously up, the number of heads that may show up will vary from 0, 1 or 2. And if you find out the respective probabilities for them, what is the probability that 0 heads will come up or 0 heads will show? Okay, in this experiment, 0 heads, see here, sample space, 0 heads, there is only one such possibility. So you have 1 upon 4, 0, total number of outcomes are 4. So n of a upon n of s. N of a are 0 number of heads. So remember, this represents number of heads. Okay. This represents number of heads x. So it can be 0, 1 or 2. So what is the probability that 0 heads come up? Only once you have 0 heads coming up here. So that is 1 divided by total number of outcomes here are 4. So 1 divided by 4. On the other hand, what is the possibility that one head will come up? So one head comes up two times, this one and this one, right? So we have 2 upon 4. And what is the possibility that two heads come up? This is the possibility, only possibility. So we have 1 upon 4. This is nothing but what we are doing is we are associating a probability with every outcome. Okay, that is nothing but a random variable, and in this case x is a random variable. Okay, so now just a second. Okay, so a random variable is a function which assigns a real number. We were assigning a real number to every point in the sample space. To every point in the sample space, we were assigning a real number in terms of probability. So that was about random variable. Random variable is broadly classified into two types. It can be either a discrete random variable, or it can be a continuous random variable. So what is a discrete random variable? The definition for discrete random variable is like this. You have to by heart this. There is no other way for this. A random variable x, which takes the specified values x1, x2, x3, x4, dot 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 up till xn. So there are n number of values possible, and the possible values of x that x can take is x1, x2, x3, x4, x5, x6, x7, x8 and so on up till n. So up till xn with the respective probabilities of p1, p2, p3, p4 up till n. That means x1 has a probability of p1, x2 has a probability of p2, similarly x3 has a probability of p3, x4 has a probability of p4, and similarly all we have xn has a probability of pn. Then x is said to be a discrete random variable. Example of such, in a previous example which we had taken, 2 coins are tossed up simultaneously, where we had the sample space HH, HT, TH, TT. You should know the meaning of this. I have told you in the previous module. HH means the first coin is head, turns head. The second coin also turns head. Here the first coin turns head, the second coin gives tails. Here the first coin is tails and the second coin is heads, and here both the coins turn up tails. Okay, so that is the meaning of this. So suppose two pair coins are tossed up. The sample space looks like this. Let the number of heads in each case be represented by x. The same example which I have told you in the previous slide is explained here. Then x is a function on the sample space, right? Because sample space will give you all the outcomes, and x, what we are saying is x be the number of heads. Then it can be, I get the value, what all values it can take, 0, 1, 2. That means either you can get 0 heads, 1 head or 2 heads with respective probabilities 1 upon 4, 1 upon 2 and 1 upon 4. If you write this in the form of table, it looks like this. That is sample space, that is sample point. If you see TT, 0 number of heads, TH, 1 head, HT, 1, and HH, you have 2 heads. Now a question will come, why only heads we are taking? Can we take tails? Yes, you can take tails. If you want, you can count the number of tails, but in this case we are just finding the number of heads. Okay, a similar problem you can do for number of tails also, and it will be just reverse. It will give you values 2, 1, 1, 0. Okay, so this is about discrete random variables. You have full whole number values here. Continuous random variable. A random variable which assumes all the possible values in its range is called a continuous random variable. Okay, suppose 2 coins are tossed up and you get the sample space HH, HT, TH, TT. Let X denote the height of the group of students. Then X is a continuous random variable. Now in this case, the first example which I had given you here, this example tells you about discrete random variable. Okay, this example is of discrete random variable. Yes, discrete, okay, random variable. Whereas this, where we are talking about the height of the students, okay, the height of the students is given by suppose represents x, then x represents a continuous random variable because it can take any value within the range. Within the range means it can be anything. It can be 5 feet 4 inch, it can be 5 feet 5 inch, it can be anything between 5 feet 4 inch also and 5 feet 5 inch also. Basically, discrete means you have whole numbers generally, and whereas continuous variables means you can have anything in the continuum, that is from this point to this point. Like for example, you can say count the number of boys in the class. Okay, when you are saying count the number of boys in the class, you will get discrete variable because you can count. You cannot say there are 5.6 boys. Either you will get 5 boys, 6 boys, 7 boys, 8 boys, so whole numbers. Whereas when it comes to continuous random variable, it can be anything. For example, if a tank is there which consists of liquid or say water, and there is a tap attached to it, and you run the tap on, water starts falling. After say, some seconds, you say that stop. So you stop the cork and you measure how many liters you have of water you have got in the bag or in the bucket. This represents, that is the number of liters that of water that is there in the bucket, represents continuous random variable because you can have any value. It can be 1 liter, it can be 2 liters, it can be 3 liters, or it can be anything between 1 and 2 or 2 and 3 liters also. So it represents continuous random variable because it can take any value. Now coming back to the next concept, that is probability mass function. Now remember, mass function, whenever I am talking about probability mass function, is applicable only for discrete random variable. When we are talking about continuous random variable, we have density functions. So probability mass function, abbreviated as PMF, let x be a discrete random variable and p of x be a function such that p of x equal to x. What is the meaning of this? When random, the meaning of this is when a random number x takes the value of x, that is x, and this number can be anything. Okay, x, and this number can be anything. It can be 1 head, it can be 2 heads, it can be 0 heads, so it can take any value. Okay, so p of x, when x equal to x, then probability of x is the probability mass function of x if the following two conditions are satisfied. What are the two conditions to be satisfied? Normal conditions, these are: the first one says that probability should be greater or equal to 0 for all x. Yes, you cannot have negative probability mass functions. You can have either it can be 0 or it can be more than 0, and also it cannot be more than 1. So probability p of x should be greater than 0 or equal to 0, and it cannot be greater than 1 also. And the second point says that the summation of p of x should be equal to 1, that is sum of all values of p of x is equal to 1. Let's go to an example which we have taken earlier, and I'll explain you both these conditions. The first condition says that p of x, here all values of p of x should be positive, that is greater or equal to 0. Let's see whether it is the case or no. Now in this case, look at the table below. Now in the table below, you can very easily see that one, as no heads are there here, one head is there, one head is there, two heads is there. Respective probabilities, if you write p of x for these things, for 0 heads, okay, for 0 heads, what is the probability? 1/4, right? For 1 head, these both will combine together and become only 1. Okay, for 1 head, What is the probability? It is 1 upon 2. And for 2 heads, what is the probability? It is 1 upon 4. Right? So this is a probability mass function. Now in all this case, you can see that the values which I am writing is greater than 0. Right? This is 0.25. If you solve this on the calculator, this is 0.5, this is 0.25. So all the values are greater or equal to 0. And also the second condition, if you add up all the probabilities, 1 upon 4 plus 1 upon 2 plus 1 upon 4, you will get answer is equal to 1. So both the conditions are satisfied here, right? Both the conditions are satisfied. So this is about probability mass function. Remember, probability mass function is applicable only for discrete random variable. For continuous random variable, we have the second concept, that is probability density function. So what is probability density function? Generally this is not asked in your examination, just for this, because it is there in the syllabus. I am explaining this part. Let x be a continuous random variable taking values in the interval a and b. Now I am talking about an interval a and b. So between a and b, any value it can take. I am not saying it will take whole numbers only, or 1, 2, 3, 4, these kind of numbers it will take. I am not saying it can take any value between a and b. So a function f of x is said to be the probability density function of continuous random variable x if it satisfies the following conditions. So a function f of x is said to be a probability density function. So when can we call it a probability density function of any random variable x? When there are 3 conditions that are to be satisfied. What are these 3 conditions? The first 2 conditions are similar to the previous, that is PMF conditions. Let's see one by one. Now in this, all f of x should be greater than equal to 0 for all values of x. Okay. Then second one, for 2 distinct numbers c and d in the interval a and b, probability of x between c and d is equals to area under the probability curve between ordinates at x equal to c and x equal to d. And the third condition says that total area under the curve is equal to 1. So this is like your second condition, this is like your first condition, this is the new condition that has come up here. Okay, total area under the curve is equal to 1, that is probability between minus infinity and plus infinity is equal to 1. This property we are going to use in our next model very much, because there you are writing diagrams where the area under the normal curve will be always equal to 1. So now let us take this into consideration. What are these? Function of x greater, the value of function of x should always be greater or equal to 0, that is it should be always a positive value. Okay, in any interval a and b. Suppose there this is a continuous function here, this whatever line is there is a continuous function. Okay, now there are 2 points. Okay, I have taken x equal to c and x equal to d. This is x values. It starts say somewhere from 0, 1, 2, 3, 4, 5, 6, 7 and some number it is there c, and there is some other number which is equal to d. Okay, now when I am taking these 2 numbers c and d and I am finding out the area between them, or what is the probability that x lies, okay, that the number that is a variable lies between c and d. So this is given by area under the shaded region. So area under this, so if you find the area, just draw perpendiculars from this and this perpendicular lines and find out the area that is there between this area that is shaded region gives you the probability of that x, that is this random variable x lies between c and d. Okay, so this is the second condition, and the third condition says that the entire area that is under the curve, this entire region which is there, that is equal to 1, that is 100%. So these are the three conditions need to be fulfilled when we are talking about PDF, that is probability density function. Remember, probability density function is considered only for continuous random variable. So let's take the next part, that is probability distribution. Now what is probability distribution? In the first example also I have taken shown you a table where x had taken various values. X can take 0, 1, 2 when you toss a coin up, and x is the number of heads that are observed. Then this table which is there, which we draw, and which gives you the probabilities of each and every item or happening in the sample space, then that is nothing but the probability distribution. For instance, by definition, a systematic what is probability distribution? It is a systematic presentation of the values taken by a random variable, okay, with their respective probabilities, is called probability distribution of a random variable x. Suppose if in this itself example, number of heads it can take, okay, x is suppose number of heads, then the number of heads that are possible is 0, 1, 2. I have taken one extra here, and this is x. X represents number of heads. When you toss 2 coins up, so it can be 0 heads. So what is probability of x, small x here? 0 heads. So it is 1 upon 4. This is 2 upon 4, that is 1 upon 2, and this is also 1 upon 4. So this is how you solve it. So this is nothing but probability distribution of what experiment? When you toss 2 coins up simultaneously, and where x is nothing but it is the number of heads that turn up. Okay, so for today we shall stop here. From the next class we shall take some problems on random variables. From this syllabus, that is third module, you won't be asked much of theory. When it comes to theory, I'll just go back and I'll tell you definition of a random variable is important. Many times this has been asked for 2 marks. This definition which is there of random variable, this is generally asked for 2 marks. So if you write only this much, you will get 2 marks. Then similarly, this discrete random variable they have never asked so far, but I feel that they may ask. So remember this one, definition of discrete random variable. So only these 2 are there which are generally asked. This continuous random variable examples, nothing has been asked. You can read little bit about probability mass function, the third point which I am talking about. So these 3, if you 3, and the fourth definition from this is probability density function. So if you prepare this, I think from your exam point of view, so not this one, this one, probability density function. So if you read this much, I think it will be more than enough for 2 mark section. Out of these 4, one definition they are gonna surely ask in 2 mark section. Apart from that, it is only problems that they will ask from this section. 1 10 mark section and 1 5 mark section can be asked. So from next class onwards we shall solve some problems on this. If you have any doubts with the lecture, you can contact me. Theory is little something which you may not understand. If you have any doubts, you can contact me, or else these are definitions, you can mug up the definitions also. But in case of clarity, if it is needed, you can always contact me to understand the concepts and theory about this. Okay, so we end the lecture with this note.